Hello, Year 11. So this is our lesson on magnetic fields today, and we'll start like always with our KIP quiz. I seem to be saying the same thing actually when I do these recordings. So KIP quiz then on our mini whiteboards, 1 to 5 on your mini whiteboards, and let's have you pause the video. You should know what we're doing by now because we're doing it in the same routine every lesson. So pause the video and give yourself a few minutes, 3 to 5 minutes to complete these 5 key terms and definitions. Okay, so you should have your 5 answers now, and let's check to see if you've got them correct. So number 1 then, a positive test for oxygen gas is that a glowing splint relights. Second question, positive test for hydrogen gas, a squeaky pop upon ignition. So when you've lit a splint, you've got a squeaky pop sound. Test then for carbon dioxide, a positive test would be cloudy lime water. Or you could call it milky as well, but that's what it says in the knowledge organiser. And number 4 then, positive test for chlorine gas. So we're looking for bleach damp litmus paper. And then lastly, number 5, a quantity with only magnitude and direction is a scalar quantity. So marks out of 5. And then let's get ready to proceed with the lesson. So you'll need your normal pen and your knowledge organiser book, or just a book that you're using at home, and a purple pen for tasks later on in the lesson. Okay, so our lesson today is on magnetic fields. So we'll be looking at magnetic fields around a magnet, but also around the Earth itself. So our learning objectives today then are to know that the region around a magnet where a force acts on another magnet or on a magnetic material is called the magnetic field. The force between a magnet and a magnetic material is always one of attraction. The strength of the magnetic field depends on the distance from the magnet. The field is strongest at the poles of the magnet, and we'll look at how you can look at the lines on the diagram to show this. The direction of the magnetic field at any point is given by the direction of the force that would act on another north pole placed at that point. So although this is quite a complicated objective, when you actually see it as a diagram, it is far easier to understand. Okay, so here we have our input for magnetic fields. Okay, so here we have a bar magnet. So we've got our bar magnet in the middle of the diagram with our north and south poles identified. And you can see that we've got these lines around the magnet, and that tells us that we've got a magnetic field. So obviously in real life we cannot see the magnetic field, but this is just displaying what they would look like, okay? And can you notice how the lines are coming out of the North Pole and then they are going towards the South Pole? Okay, so the lines are going out of the North Pole and then they are going to the South Pole. So that is always the case. The magnetic field lines always start at the North Pole and then end at the South Pole. So we show that with the little directional arrows on the lines. Notice how as well that if we have the lines really, really close together, then the magnetic field is much stronger at this point. So where we've got at the North and the South Pole, all of the lines really, really close together, that means the magnetic field is stronger at this point. Lines that would be further apart would represent where the magnetic field is weaker. And as you move further away from the magnet itself, the magnetic field or the force that's experienced would be weaker further away from the magnetic field. And it would be well worth at this point making a revision card on magnetic fields. So pausing the video and getting yourself a revision card and then just drawing this diagram and then sort of annotate with the notes in yellow. So the fact that the magnetic field lines always start at the North Pole and then they move round towards the South Pole. When they're close together, the force is strong. And you can see that where it's strongest at the poles. And then lastly, the strength of the magnetic field depends on the distance from the magnet. So make yourself a revision card. Okay, so on your mini whiteboard then, please, what I would like you to do are 2 different diagrams. So you've got the bar magnet with your north and south pole. So how would you draw the lines? From what pole would the lines be coming out of and which pole would they be going into? How would you then put the arrows onto the lines to show the directions? Where would you have your lines all really, really close together, and where would they be quite evenly spaced? So draw the diagram of the magnetic field lines around a bar magnet, and you should be doing this on your mini whiteboard, and it shouldn't take long. And then your second diagram is you've got a diagram of a North Pole next to a South Pole. So what would you expect to see here? How would you draw the lines? Remembering the rules about where the lines always go from and to. Now, I'm not going to give you too much instruction for diagram 2 because I just want to see what you come up with. So draw 2 diagrams, please, and be ready to review them. And remember, draw a continuous line. So this is not a kind of blurry or feathered or etched line. It's just one continuous line coming from one pole to the other, and then show the direction with some little arrows. Okay, so you've had some time to draw these 2 diagrams, and you should have something that looks like this. So for your first diagram, it's just like the previous one that I've shown you, and it's really important that you check that your lines are coming from the North Pole and going round to the South Pole, and you're showing that with the arrow. And then it was the second diagram that I really wanted you to sort of do and use your kind of thinking processes for this. So you should have, going from the North Pole on the left-hand side, arrows going all the way over to the South Pole on the right. So it's just lines. Doesn't matter how many lines you've drawn, although the diagram shows 3. If you've done 2 or 1, that's absolutely fine. But have you got an arrow on there as well to show the direction? So this is what you should have. And the reason I've put in the second diagram is that there are sometimes exam questions where they just try and trick you a little bit, or try to confuse you by giving you a slightly different example. So hopefully seeing it now means that if you saw it in a paper, you wouldn't sort of stress at that type of question. Okay, this is one of my favourite things in science, and I'm going to give you some thinking time on this now. So we're now looking at the Earth's magnetic field, and I need you to find the hidden bombshell in the diagram. So are you looking at the diagram? Are you looking at where the magnet is? Are you looking at where the poles are? Because in just a few moments, I'm going to drop the bombshell. Okay, are you ready? And if you're not ready and you want some more thinking time, then pause the video. But if you are ready to find out the hidden bombshell, then carry on with this video. So look at how the bar magnet is arranged on the diagram of the Earth. Look at how the North Pole is actually at the bottom and the South Pole is at the top. Look at how all the lines are coming from the North Pole and going up to the South Pole. And did we not all think that the North Pole was actually at the top? No, it's in the wrong place. And so whenever you go looking for Father Christmas, if you travel to what you thought was the North Pole in the northern hemisphere of planet Earth, you're going to the wrong place, because Father Christmas is actually hiding down at what we call the South Pole, but is actually the North Pole. And you may be wondering, well, why is that? Why do we say that the North Pole is in the northern hemisphere and the South Pole is in the southern hemisphere? Well, it's to do with their names, because remember, the North Pole, I said in the previous lesson, was the north-seeking pole, and the South Pole was the south-seeking pole. And so the lines that are coming out of the diagram at the bottom, they are seeking north, and then they're finding it at the other side. So you will not find Father Christmas at Lapland. Sorry guys, he's not there. He's not actually in the northern hemisphere. He's hiding somewhere down in the southern hemisphere, and that's why we've not found him. Okay, so in real life though, in all seriousness now, forgetting Father Christmas, it is time to make a note of this diagram. So just draw a diagram of planet Earth, a simple circle with the line for the equator. Don't worry about putting continents on or anything like that. and then add the bar magnet. Notice how planet Earth is on a slight tilt, and then draw the lines coming out from the bottom going round to the top. So use the arrows to show the direction of the field lines. So it's really important that your lines are coming out of the North Pole at the bottom and are moving round towards the top, and that you have arrows to show the direction. Okay, so pause the video to give yourself time to do this. Okay, so this is now a video of a practical that we would have done actually in classrooms with bar magnets and little compasses. And the reason that we would do this in a classroom and that you're going to see a video of this now, even though we're on remote learning, is that often you are asked method questions linked to this practical. So watch this video now and then we'll go through the method.
Good morning. Last lesson we learned a little bit about magnets and magnetism. Today you are going to do a practical to see if we can get some sort of idea of what a magnetic field would look like if you could see it. Here we go. So to carry out the experiment, we're going to need a magnet and a plotting compass, just like the one we used last time to find all the hidden magnets. The first thing you will do is draw around your magnet, because you're not allowed to keep the magnet. So I want to record exactly where the magnet was on your page. You draw around the edge of the magnet. Then you bring the plotting compass up to one end of the magnet. Got it up to the blue end there, and you'll see that the compass has now aligned itself, or the arrow in the compass has aligned itself with the magnet. To get an idea of what the field lines look like, all we do is we put a little point. Once you've got the compass lined up like that, you put a little point where the arrow is pointing, and then you move the compass so the tail of the arrow is pointing at the little dot that you've just made, and then you make another dot. And then you move the compass again, so the arrow of the compass is pointing at the dot that you just drew. You put another dot where the arrowhead is pointing. We move the compass again, so the tail of the compass is pointing at the dot you just made. And we put a dot where the arrowhead is pointing. And you keep doing that until you get to the edge of the page. Once you've got to the edge of your page, the edge of the sheet of paper, you will join up all the dots and put an arrow in the direction that your compass was pointing. Once you've got one magnetic field line in there, you're going to do the same thing, but you must start the compass from a very slightly different position. Now you'll see, if I start from a slightly higher position on this end of the magnet, you see the arrow is pointing in a slightly different direction. So now if we were to repeat what we did last time, we put a dot where the arrowhead is pointing, then we move the compass so the tail is pointing at the dot. We put a dot where the arrow is pointing, then we move the compass so the tail is pointing at the dot you just drew, and so on. You will get a slightly different magnetic field line. And again, you go right to the edge of the page, you draw in your field line, you join the dots, and then you put an arrow showing the direction that the compass was pointing. And then we go back to the magnet again and repeat from a slightly different starting position. I would like you to draw field lines from a whole range, 6, 7, 8, 9, 10 different positions around the top. Can you see how the arrow is changing direction there? And whatever starting positions you have above the magnet over here, I would like you to do the same from below the magnet. Okay, if you finish and come and see me, you could repeat the experiment with one of our neodymium supermagnets. Okay, off you go.
Okay, thank you very much for watching that video. That guy had freaky eyes. Right then, so like I said, we would have been doing this in class, and I'm really sorry, obviously, because of the lockdown, that means you're doing all of your lessons remotely, so you won't get to do it. hopefully maybe when you come back, we might be able to go through and do some of the smaller practicals, maybe in lessons that you haven't been able to do. And I know that you'll be really sad about missing out on this practical to do with bar magnets, compasses, and a bit of paper and some dots. But in all seriousness, we do need to know the method. And it's a really precise method. When we mark this type of question, we're looking to see that you've got the method in the right order. So it's really important that you now come up with a technique for remembering the order of this method. So again, you could be pausing the video now, writing this out on a revision card, and then testing yourself. But you need to be sort of practicing by writing this method out multiple times and then checking it against the original revision card. Are you getting it in the right sequence? So this method then, you place the magnet on the piece of paper and you draw around the magnet, and you would mark the north and south poles. Then you place a compass by the pole, so obviously at one of the ends of the magnets, and you make a dot at the tip of the compass needle. And you saw the man on the video do that. You then move the compass tail to the new dot and make a dot at the tip, again, so the tip of the arrow. Repeat until the compass reaches the other pole of the magnet. So you're going to go around in a circle, and I'm going to show you an example in a minute of what that looks like. Draw a line through the dots and then add arrows to show the directions of the field lines from north to south, remembering those field lines are always going from north to south. And then just like on the video, how he showed he would repeat it for different starting positions, you would change that starting position of the compass and then repeat so that you get those multiple lines coming from your compass. So this is where I did just a practice example. And so I've got my bar magnet, I've placed it on a piece of paper, I've drawn around the magnet, I've labelled my north and south poles, and then you can see I've got the dots on the piece of paper and it's gone round and completed a full circle. And then you join up the dots, you draw a line, and lastly you add those arrows to show the direction of the field lines going from the north to the south pole. The only limitation of this diagram or this image right now is that I haven't repeated it with sort of multiple starting points. So what I should have done is then moved the compass to a different starting point, and so that I would end up with those multiple lines going round on the diagram. Okay. So remember, the most important thing is that you can sequence that method. So like I said, create a revision card, sort of take the video back just a moment, rewind it, and then create that revision card. And then in the future, you need to practice writing out that method and getting the sequence, the order correct. Right then, time for some exam questions. So you can do this one on a mini whiteboard, or because this is a remote learning lesson, you can just kind of point at the screen and find out if you've got it correct. So a magnet produces a magnetic field. Which diagram shows the magnetic field pattern around a bar magnet? So I'll just give you a moment to think, and hopefully it becomes fairly obvious which two it's definitely not. And 5 seconds later, you should have this one. So obviously it wasn't the bottom two, and I hope you know that. So it's this one because the lines are going from the north to the south pole. Okay, so that's why that one is the answer. And here we go then. So here's that exam question. Describe a method using a compass to plot the magnetic field lines around a bar magnet. So at this point, this question was worth 4 marks. And remember what I keep saying, that the best answer would include all of the key steps in the right sequence. And remember, that starting point was that you'd place your magnet on the piece of paper. What would you do next? What would you do after that? What would you do after that? Okay, so if you've made your revision card, then well done you, because now you're ready to go. And see what you can do from memory as well. See what you can remember. So pause the video, give yourself 4 minutes, and then resume the video. Okay, and then here are the answers. So what I'll do is I would ask you to look at the level 2 guidance. If you've got all the key steps and if you've put them in the correct sequence, that is how you would get 4 marks out of 4. If you've got some of the steps but you've forgotten some, then I would award yourself 2. So it's a case of, have you got all of the key steps and are they in the correct sequence? And if they are, then that's 4 marks out of 4. But if you've got some steps missing, like you forgot, for example, to make a dot at the tip, or you forgot to draw a line through the dots and you didn't write that, then I would give yourself 2 out of 4. Okay, so that's the end of our lesson then. Remember to click on the Seneca links now as well, and the BBC Bite Size links for some additional learning and checking. So thank you very much. See you tomorrow.